This is our block presentation by Audrey Shano,
Melina Croft,
Anna Bach,
Jack Plisky.
We did the F block, also known as the intertransition series, is made up of lanthanides and actinides, and here's an introduction to lanthanides.
Lanthanides, rare earth metals, 57 and 71 on the periodic table. And lanthanum, my symbol is
LA.
atomic numbers, 57, atomic mass is 138. Hello there, I'm cerium. My symbol is CE, atomic number is 58, atomic mass is 140. I believe PR, atomic number is 59, 140 is my atomic mass, by far. Neodymium, my symbol is ND, atomic mass is 144, atomic numbers 60. Atomic numbers 61, chromium, atomic mass is 145, my symbol is helium. Atomic numbers 62, I'm samarium, my atomic mass is 150, my symbol is SM. Atomic numbers 63, I'm europium, my symbol is ZU, atomic mass is 151. GD is my symbol, I'm galonium, my atomic number 64, atomic mass is 157. Tritium, my atomic mass 158, atomic number 65. TV's my symbolism. Isn't that great? My name, atomic number 66, my symbol is DY, 62 is my atomic mass mix. Ammonium, my symbol is HO, atomic number 67, atomic mass is 64. My symbol is AR, I am erbium, atomic number 68, atomic mass is 167. My atomic number is 69. Polonium, my atomic mass is 168. My symbol is TM. I'm a terbium, my atomic mass 173. My symbol is YB. Atomic numbers is 70. My symbol is LU. I am lutetium, atomic mass is 174, atomic number is 61.
lanthanides. Lanthanides include elements 58 through 71. These are also known as the rare earth metals because their natural quantity is less than 1% on Earth. Most of these are made because uranium and plutonium go through nuclear reactions. Lanthanide contradiction. Their size decreases with the increase of mass number. This is because of the f orbitals.
Uses for lanthanides. Lanthanides are used in hybrid cars, superconductors, and permanent magnets.
Some lanthanides are used in oil refining industries to speed up the conversion of crude oil, crude petroleum into gasoline, for example. Lanthanides such as yttrium are used to make the color red in televisions. Some are used in street lights and high-powered lights in sports stadiums.
Lanthanides are also used in the ceramic industries, and uses are to color their glasses and ceramics. Lanthanum oxide is used in the optical lenses used for binoculars and cameras, also made in TV screens to reduce the glare.
Cerium. When a Swedish chemist Axel Crodsen first discovered cerium, he thought it was a new form of tungsten. He found it in a mine close to Sweden. Later, when other chemists testified the element he found, they decided it was something new and named it cerium. Among the applications for cerium is an alloy called mischmetal. It is made of the chlorides of cerium, lanthanum, neodymium, and praseodymium. The alloy that comes from that ignites at or below room temperature and is usually used as the flint in a cigarette lighter because it sparks when friction from a metal is applied.
Actinides. The actinides includes elements 87 to 103. It comes from the Greek word actis, which means beam or ray. These elements are radioactive. They are typically soft silver metals. Some could even be cut with a knife. Actinides have the same properties of the D block. All of the actinide elements have crystalline phases. The number of electrons doesn't affect the melting point of the actinides. None of these occur in nature other than uranium.
Uranium. The scientist that is credited with discovering uranium is Martin Heinrich Klaproth. He named it after the recently discovered planet Uranus. Uranium has been in use as far back as ancient Rome and during the Middle Ages, when its orange-red to lemon-yellow shades were used as coloring agents in ceramic glazes and glass. Uranium's melting point is 3,818 degrees Celsius. Uranium ranks 48th among the most abundant elements found in nature, natural crustal rock.
Uses for actinides. Actinides. Americanum is part of the actinide group, which is used in smoke detectors. Because these are so radioactive, different actinide elements are used in cancer therapy because the radiation kills the cancer cells quickly.
Nuclear bombs. The world's first nuclear explosion was used with plutonium-239. The world's second explosion was uranium-235.
Actinides and lanthanides are highly reactive, especially with elements from the halogen group. Group 17.
First of all, the lanthanides are all metals. Here's a selection. Here's lanthanum, samarium, dysprosium. If it's heated in chlorine, dysprosium forms a trichloride, and all the other lanthanide metals do the same. Chlorine oxidizes all of them to the +3 oxidation state. But the simplest way of reaching this oxidation state is to dissolve the metals in dilute acid. Here's praseodymium. Hydrogen is evolved, and if the reaction is done in air, then whatever the lanthanide metal, the final product is the aqueous tripositive ion. In this case, it's green. Compounds or ions in other oxidation states are much less stable. For instance, the dipositive aqueous ion of samarium can be made. It's blood red. But it's quickly oxidized by water or hydrogen ions to the pale yellow tripositive ion. The highest known oxidation state of any lanthanide element is +4. The most stable example is cerium-4, which occurs in cerium dioxide. This is almost colorless. Sulfuric acid converts the dioxide to a sulfate of cerium-4. It consists of orange crystals. When the orange sulfate is dissolved in water, the orange tetrapositive aqueous ion is formed. But even cerium-4 species are easily reduced to the +3 state. We'll use hydrogen peroxide as the reducing agent and add it to the orange aqueous ion. Oxygen is evolved as the cerium-4 is reduced. The colorless product is the aqueous tripositive ion of cerium. So for all of the lanthanides, the +3 state is very stable to oxidation or reduction. The lanthanide series, which begins with lanthanum and ends with ytterbium, is a set of unusually similar elements. Take a little time to study the pictures and information that we've provided on the different metals. And as you examine the reactions with acid, ask yourself how these elements differ from the reactions that you studied earlier in the transition metal program.
Conclusion. The F block is made up of two series, the intertransition series, known as actinides and lanthanides. These elements are radioactive and highly reactive with the halogen groups. There are many uses in our daily life with the F block, even if we don't always realize it.